Hello everyone, welcome back to Technical Professor. So in this lecture, we are going to understand one of the most important foundation for machine learning, that is probability. And probability helps machine models to how to deal with certain uncertainty which exists everywhere in the real world. So let's get started. So what is the importance there? So machine learning does not give absolute answers. Instead of saying yes or no, models say models usually say things like there is 90% of chance, which I will increase the size of text. No, that's fine. So, so machine learning does not give absolute answer. Instead of saying yes or no, models usually say like there is 90% of chance that email is spam or not. So probability allows models to measure confidence and handle noisy data and make better decisions. So without machine learning, would simply be guessing. Okay, so that is importance there. That is, it helps to understand uncertainty and confidence in data and decision making. Okay, so what is probability? So probability measures the chance of event occurring. Means how likely and event is to happen. Its value is between 0 and 1. So 0 means impossible and 1 means guaranteed. So most real world ML prediction falls somewhere between 0 to 1. All right. So now we are going to understanding basic probability formula. So the basic probability formula will be favorable outcomes divided by total outcomes. For example, one we toss a fair coin, so total outcome will be 2. And favorable outcome for head will be 1. So probability will be 1 by 2. Okay, of getting head. Like this is coin, there is head and tail. So there will be total outcome will be 2. There will be head and one tail. So how total head or tail, that is 2. And what we want to calculate, that is head, that will be 1. Okay. So now we are going to understand random variables in ML. So random variables define outcomes in machine learning. So In machine learning, we use random variables, and a random variable represents the numerical outcome of uncertain event. So, example, number of clicks in advertisement, and whether a user buys a product or not, email is spam or not. So, ML models are designed to predict those random variables. Okay, number of click, emails, these all are examples of random variable. Okay. So now we are going to understand discrete versus continuous probability. So it is divided into discrete probability and continuous probability. So discrete means yes or no, or spam or not. But in continuous, house prices, temperature, and stock prices. So classification problem generally uses discrete probability while regression using continuous classification, discrete, but continuous regression problem using continuous probability. So now we are going to understanding probability distributions. So probability distribution shows how probability are spread across different values. How probabilities are spread. It helps understand which values are common, which values are rare. So machine learning models try to learn this distribution from data. Okay. All right. So now we are going to understand Bernoulli's distribution. So, Bernoulli's distribution has only two outcomes, that is 0 and 1. This is perfect for binary classification. Tasks such as spam detection and fraud detection. And logistic regression is based on this idea. All right. So now we are going to understanding binomial distribution. So binomial distribution used when we repeat a Bernoulli's experiment multiple times. Experiment multiple times. So example will be we are going to predicting how many users will click and out of 100 users. So distribution helps ML model repeated binary events. All right. So now we are going to understand normal distribution. In normal distribution, this is called bell curve also. Here it is. That is appear frequently in real data. So example will be heights of people, exam score. So many ML assumptions are based on idea that follow a normal distribution. So now we are going to understand what is mean and variance. So let's see. So mean represents average value and variance tell how spread out of the data is. So together means and variance describe the shape of probability distribution. So now we are going to understand conditional probability. So conditional probability answer this question. So what is probability of uh, event A given that event B has been already occurred? So this concept is important in machine learning. Okay. This the formula will be. So this is the formula of conditional probability. Okay. So ML models constantly update prediction based on new information, just like this. Okay. All right. So now we are going to understand conditional probability in education. So let's see. So conditional it analyzes student path rate effectively and evaluating success is based on various factors. Okay, now we are going to understand bias theorem. So let's see. So bias theorem help allow us to update probability when new data arrives. So let's see. It is one of the most important powerful ideas in machine learning. So examples are spam detection, spam detection. So given the word in the email, bias theorem helps to estimate what is probability of email is spam or not. Okay. So medical diagnosis also use this logic. Bias theorem. Okay. So probability in classification models. So in this classification like logistic regression, output will be probability. For example, in 85%, there is 85% chance that customer will churn. So final decision is based on probability. Okay. So now we are going to likelihood. So likelihood measure how well a model explains observing data. So during training, ML models try to maximum likelihood. So meaning they are try to make the observed data as probable as possible. Okay. So now we are going to learn understanding what is loss function. So many loss function comes from probability theory. So examples are log loss and cross entropy. So lower loss means higher probability of correct predictions. Okay. What does it mean? Lower, higher probability of correctness. So now we are going to understand naive bias algorithm. So naive bias is simple but powerful algorithm based on probability. So it assumes features are independent, which is not always true, but works surprisingly well in practice, especially for text policy classification. So now we are going to understanding uncertainty. So probability allows ML models to explain uncertainty. So it is critical in healthcare, finance, and autonomous systems. So being uncertain is often safer than being outconfident. Okay. So now we are going to understand decisions threshold in ML. So probability are converted into decision using threshold. So if probability greater than zero point 0.5, it is positive. Otherwise, negative. Okay. So different application use different thresholds. All right. So what are the common beginner mistakes? So treating probability as absolute truth, that is mistake there. And first and second one is ignoring uncertainty. And third one is using default threshold blindly. So good ML engineers always question probabilities. Okay, so how much probability you really need? That is practically. So you don't need our advanced probability theory to use ML effectively. You need basic, conditional, and bias. So this is enough for most machine learning models and tasks. Okay. So real world applications are spam filtering, spam detection, medical diagnosis, and finance analysis and recommendation system risk analysis. So these are real world applications. So almost every ML system relies on probability. So what is summary of today? Let's try to summarize probability. What probability do? Probability helps ML model, ML handle uncertainty, and model predict confidence, not certainty, and probability theorem plays the central roles. So in this next lecture, we are going to cover statistics for machine learning. All right. So where we learn how to understand data before building models. So if this lecture helped you understand probability better, like the video and comment statistics for the next lecture. Thank you so much for watching this video. Bye bye. Take care.